So we're going to look at a little bit at solving one-step equations. And the first example, we're just going to go by examples here, is x plus 4 equals negative 12. So by the subtraction property of equality in the equality notes on properties, we can simply say x plus 4 minus 4, because what we're trying to do, the whole goal is to isolate, the goal here is to isolate the variable. Isolate x. So if we're going to do it to one side of the equation, we have to keep it balanced and do it to the other side. So in this case, we can look at it this way. Some of us might be a little more comfortable saying x plus 4 equals negative 12. You can put it underneath, which that way gives you a little better check vertically to say plus and minus, and we know that that's going to give us the 0 and be able to move that piece over to the other side of the equation. X equals negative 16. Okay. So that's one example. Let's look at a different one. Let's look at one that has division in it. It starts out at division. So this one, negative x over 3. So a negative x divided by 3 and equals 27. So still, the goal here is always to isolate x. So how do we get x by itself? Well, it's being divided by 3. And it also has a negative out in front here. So we could say that this is 1/3 times x equals 27. All I did was give the same equivalent property of negative x over 3 as negative 1/3 x. So since it's being multiplied by a fraction, we can take this and multiply by its reciprocal. If I take negative 3 over 1 times negative 1/3, the result of this is just going to give me 1x, which is essentially the same as isolating x. But whatever I do to the left side of the equation, got to keep it balanced and do it to the other side. Now I can say negative 3 over 1, but I know that negative 3 over 1 is negative 3. And the result is negative 81. Okay. Well, let's check that. Let's check to make sure. So take the original equation and let's see how that result piles up. So I've already got a negative. And it's saying, my work is saying I've got negative 81 as a solution divided by divided by 3, not x. And that's supposed to equal 27. So before I do anything here on division, I want to do this multiplication on the numerator, which is really that negative 1. So I get a positive 81 over 3 equals 27. 81 divided by 3, if we check that, 27 equals 27. And you should get in practice of substituting what your result is to check your work. And if it checks out, we should get this reflexive property. We're going to take a look at two-step equations. So I'm going to start with an example and see what we can carry out of this. So if you look at this, our variable here is y. So it's the same goal. The goal is to isolate the variable. Now in the last problems we did x, but in this case our variable is y, so we want to isolate y. As it stands right now, it looks like we have two y's appearing in the equation. So we take a look and we see that we've got 3 times the quantity y minus 3. We've got a glaring property coming out to us, and this is just a real number property, and that is distributive. So I'm just going to write the left-hand side over again. So I'm not doing anything to that yet. we take this step by step. Now we've got a distributive property here. Remember, distributive property says 3y minus 3 times 3. We have to distribute it or multiply that first 3 to both terms inside. And we do a little bit of calculation. Haven't done anything to the left side yet. We'll hold on to that. We get 3y minus 9. So now we've got some terms. We've got some steps to do. And what we want to do is we want to isolate y. So grouping like terms is essential to solving any of these problems. So you can take these terms and put them on either side. It's really up to you. I'm just going to choose to take my variables, and I want to put my variables on the left side. Do you have to do that? That's not necessarily true, but in this case, for me, it looks easier to do this. I'm going to group the y's together. So if I'm going to take something away from a side, I have to perform the opposite operation to it. So this is a positive 3y. I want to do a minus 3y. Because essentially, you want that to just be 0, which that cancels out. But that's the idea of moving it to the other side. There's nothing left on the right side anymore. Now I have 27, negative 27, plus 3y equals negative 9. So there's our one step in solving. We did have to clean it up a little bit here by distributing. Like terms again, 27, negative 27, and negative 9. Now if I take these pieces and I want to combine them, since there's an equal sign now, I have to say opposite. Opposite. Did I do my job of canceling that and getting 0? Yeah, negative 27 plus 27 is 0. So that's essentially moved from the left to the right. And that's kind of the process that you want to take. And then negative 9 plus 27 is 18. And now 3 times y equals 18. We're not completely done because we haven't isolated y. We just want to say y equals. So opposite of multiplying is dividing. And we don't want this to be 0, but 3 divided by 3 we know is 1. So I really get 1y here. 18 over 3 is 6. And we know that 1y is the same as just saying y equals 6. Same idea. Let's check it out. Negative 27 plus 6 times, now I'm substituting, y is 6, equals 3, and then we have y minus 3, so 6 minus 3. Negative 27 plus 36, it's the multiplication. And then we have distribution, 3 times 6 minus the 3 times 3. So negative 27 plus 36. We could easily do that. I just want to make sure that you see the steps. Minus 9. So I just multiplied here. I get a positive 9. 36 is larger than the negative, and we're adding. And then equals 9, and we checked out. Reflexive property helps us to say, yeah, this is it. 6 is what y is equal to.